Hey guys, okay, so in class today we did start this first page of notes, but we didn't finish all the examples, so I told you guys I would make a video over them, and then so you'll watch this one first, and then the next page of notes that is in the other video with Mrs. Rembowski will start on page 2 right here. Okay, so just to kind of sum up this first part that we didn't go too into, well, if we just let theta be any angle in radians, and we let P of xy be the terminal point on the circle, then we define our trig functions as such. That's a lot of fancy words just to say when we have, so if I have my unit circle, okay, and let's say we land here on the unit circle, well, we know that we go counterclockwise to get our angle measures, and we do that starting at the x-axis, and so this would be my kind of initial side. And where I stop on the unit circle, that point there, that is what we are referring to as the terminal point, okay? And so from my initial side, that's always, that's going to be on the x-axis, to the line that is created by stopping at this point on the circle. We are given an angle here. This would be the theta given in any radians, and this would be the terminal point that we're referring to. And just terminal, I was about to say terminator. Terminal meaning that's where we terminated, or we stopped, right? Stopped at that point. So we already know several of these. We really have worked with all of these. Now we're just kind of putting a formal definition to them. So we know the sine is the y value. We know cosine is the x value of our coordinate pairs. And we have talked about how tangent then is related to sine and cosine. So tangent is sine over cosine, or in other words, y over x. And then we've talked about how each of these trig functions are related to another trig function. And so remember, technically all of these, if there's not a denominator, they're just technically over 1. And so notice that cosecant was just sine flipped around. So instead of y over 1, cosecant is 1 over y. Secant being 1 over x, and then notice cotangent is tangent flipped around, the reciprocal. Okay, so I'm just going to go ahead and do these examples again for any of us who maybe left earlier. So it says reference angle. Let theta be an angle in standard position. The reference angle is the smallest angle formed by the terminal side of theta and the x-axis. So that's really important, the terminal side and the x-axis. And it's always positive. Okay, so for example, letter A says find the reference angle. So I would always draw a picture first. And we're given that our angle's 200 degrees. So we always want to start on our initial side being the x-axis. We know that we go counterclockwise if we have a positive angle measure like we do. So if I go around my circle, I didn't actually need to draw the circle, but let's just say I go around, well, this we know is 180. And so to get to 200 degrees, I would just have to go an extra 20 degrees. And so this line here would be our terminal side of the angle, okay, because this is the terminal point that we stopped at. Well, the reference angle is the angle, and we did go over this one in class, it's the angle that is created between this terminal side and the x-axis. So see, I've created an angle there. Well, I know that if this guy here was 200 degrees all the way around, well, the difference between the 180 and 200 would make this reference angle 20 degrees. Okay, and notice it's the angle just between this, where we stopped on this terminal side, and the x-axis. And so remember from today in class, this is so important because we're just practicing right now, but we're gonna use reference angles to help us find exact values of different trig functions on the unit circle. And as long as we know all of the exact values that are related to the first quadrant in the unit circle, then we are able to use reference angles to figure out what those exact values would be at any angle measure. And so we'll do more examples of that in the next section. Okay, but for this one here, the reference angle is 20 degrees. All right, part B is 5 pi over 3. Again, I recommend drawing your x and y axis. All right, if you want to draw your circle, you can. I'm just not going to, just to keep it more clean. Now, we talked about today how we can break down each quadrant of the unit circle. And so we either went for radians, we went pi over 4, which was the same as going 45 degrees each time, or we increased by pi over 6, which was the same as 30 degrees. So for here, since my denominator is 3, that tells me that I got this 5 pi over 3 by going in increments of pi over 6, or in other words, 30 degrees. So 5 pi over 3, well, if I want my denominator to just say 6 to follow those increments we were going in our unit circle today in class, well, then times 2 on the denominator, also multiply by 2 on top. This would be 10 pi over 6. Okay, so I'm going to draw the little lines going every pi over 6 degrees. So remember that would be splitting each quadrant into 3. If pi over 6 is the same as 30 degrees, and we know that that's a 90-degree angle, well, 30 degrees is 1/3 of 90. So I'd be taking each quadrant and splitting it into 3. All right, so I'd have in the first quadrant, splitting that into thirds, split this into thirds, this into thirds, and this into thirds. So each of these blue lines would represent every 30 degrees on the unit circle, or in other words, pi over 6. So as we were discussing in class, if we'd go, first we'd go 1 pi over 6, then we'd go 2 pi over 6, which is the same if we simplify pi over 3. Then we'd go 3 pi over 6, which is the same as pi over 2. Then 4 pi over 6, but I'm going to simplify to 2 over 3. Then 5 pi over 6, which doesn't simplify. Then 6 pi over 6, which simplifies to pi. Then 7 pi over 6. Then 8. Then 9 pi over 6, which you could simplify that as well. And then we get to 10 pi over 6. Okay, so I just counted by 1 pi over 6 each blue line. So that tells me then that this is my reference angle. Okay, right in here. Remember again, it is from our terminal side. So that would be where we stopped at and the x-axis. So this is the angle that I'm referring to in green. And so the distance between this 10 pi over 6 and the x-axis, well, a full rotation would be all the way to 12 pi over 6, or in other words, 2 pi. So the difference between 10 pi over 6 and 12 pi over 6 would be 2 pi over 6. And so this angle is 2 pi over 6, or in other words, pi over 3 radians. And so that would be my reference angle for part B. And notice pi over 3 and 20 degrees. Those are both angle measures less then 90 degrees. So those would both fall in the first quadrant. And that's the whole point of reference angles, is we're trying to get angles that fall in the first quadrant so we can more easily find our exact values, meaning those coordinate pairs. Okay, so now we have part C. It's negative 485. All right, so again, I'm going to draw my X and Y axis. And we have negative degrees here, so that means we are going to go to the left, and meaning clockwise. Sorry, I don't know why I said to the left. Clockwise. Okay, so we'd be going this way. All right, so if I go 485 degrees clockwise, well, I know 360 is a full rotation, so that's 360. If I add another 90 degrees would be this degree measure here, so 360 plus 90 is going to get me 450. And that means that I need another 35 degrees if I'm going to get to 485. And so that means I have to go just a little bit more, about a third of the way through this quadrant. And I'm stopping here. And so there's my negative 485 degrees. And so now we want to find our reference angle. Again, the reference angle is the angle created between our terminal side, so where we stopped, and the x-axis. So if I went an additional 35 degrees here, that means that my angle created in the green, well, 90 minus 35 would give me 55. Okay, and so that would be my reference angle here, 55 degrees. All right, guys. So we did those ones in class, so now let's move on to the next section. So now, having some practice finding those reference angles, let's take it one step further and find the exact values. So part A, we're finding sine of 330 degrees. All right, well, again, I want to find my reference angle. So 330 degrees. That means I'd be going counterclockwise since I'm positive. And I know that this right here is 270. So if I'm going to go to 330, I need to go an additional 60 degrees. And so I'm going to land somewhere here. You could also think of it like, well, we know that a full rotation is 360 degrees. And so 330 degrees would have to be 30 degrees away from a full rotation. Okay, so that is our reference angle. So reference angle equals 30 degrees. So then this is where we can just go on our unit circle. So I showed you guys that table, how to memorize the first quadrant. So 30 degrees, I'm just going to do a little side note here. Don't actually write this on your notes in this space because I don't want you to run out of space. But I'm just going to do it for the purposes of the example. I gave you guys my little trick. I basically create a table and I just write my first quadrant angle measures in there. I'm in degrees for part A, so I'm not going to worry about writing the radians next to all of these. So there's my angle measures. Then I'm going to write sine and cosine. Doesn't really matter if you flip those around. It just matters that you remember that sine will start at 4. I'm sorry, sine will start at 0 and we'll work up 1 each time. So 0, 1, 2, 3, 4. Cosine starts at 4 and goes down 3, 2, 1, 0. And then for every value, you want to take the square root of it and put it over 2. So if I do that for just 30 degrees, because that's the only angle here I'm worried about, that's my reference angle. If I take the square roots and put these over 2, well, square root of 3 over 2, that won't simplify at all. Square root of 1 is just 1. And so we'll end up here with 1/2. Ran out of room there. So this is the same as 1/2. And so guys, that is super important because notice all I needed to know is this table found what the reference angle of 30 degrees is, and that is going to be the exact point of my angle 330 degrees. So I have here my point, well, my x value is cosine, so that's root 3 over 2, and my y value is sine, so that's going to be 1/2. If you go and double check on your unit circle and look at 300 degrees, you'll see that is going to be that same coordinate point I just wrote down in red. And so now just all you have to do is decide which value is negative and positive. And so if we're in the 4th quadrant here, that means to get to this point, we went positive in the x direction, but down in the y direction. So 1/2 will actually be negative 1/2. Okay, so we just found our coordinate point. I didn't actually need to find the point itself. I just needed sine, meaning I could have just directly from my table found that this was going to be that 1/2, and make sure you do double check, is that 1/2 going to be positive or negative? All right. So notice we didn't even have to memorize the entire unit circle to find the exact value at 330 degrees for sine. We just needed its reference angle of 30 degrees, and we were able to find that. All right, let's go ahead and do I'm not going to do every single example. Let's go ahead and do maybe part E first. I'm going to kind of jump around. Okay, so part E is cosine of 5 pi. So if I draw my picture, okay, well, I know a full rotation is 2 pi, okay? So if I start on the x-axis, I go around once, that's 2 pi. Go around again, that's 4 pi. And then I need to go around one more pi. Right, so that's 4 pi. I need to get to 5 pi though, so add one more pi, and we end up here. All right, so there's our 5 pi, and that's also the same as just pi, right? We know that that 180 degrees that we're at is the same as pi, and so pi then would be our reference angle. Now either you could use, for here, I would just recommend if you land on an axis, just think about the unit circle with its radius. And so remember, the unit circle has a radius of 1. So from the center to get to this point here, our terminal point, that would be backwards in the x direction, so -1. It didn't go up or down at all since it stayed on the x-axis, so the y value is 0. And if we're looking for cosine of 5 pi, that means we're looking for the x value. So this is going to equal -1. All right, let's go ahead and do part C. So cotangent of -495 degrees. So guys, I really recommend that you first, again, always find your reference angle, and then we know cotangent relates to tangent. So that could be something helpful for when we try to find the exact value here. So as always, draw x and y axis. If I go -490 degrees, think back to part C in the last section, that would be going clockwise, and you can kind of break it apart a little bit, meaning, so if I start here on my x-axis, I go clockwise, well, a full rotation is going to be 360 degrees. And so then that means I still need to go 135 degrees. Well, I know that if I get to the y-axis, that's an additional 90. So now I'm up to 450 degrees, but I still got to go 45 degrees. I have 45 degrees left. So that's actually going to be halfway between this quadrant. And so there we have negative 495. I highly recommend, guys, on these, maybe pausing for yourself, or if that was confusing, how did I get to that spot? Rewatch that, and then maybe try it for yourself without just copying down what I'm doing. So we're here at negative 495. So our reference angle, well, if I had to, from my y-axis, go an additional 45 degrees, so this angle here is 45, well, knowing that this quadrant's a 90-degree angle, as they all are, this on the other side also has to be 45 degrees. So my reference angle is 45 degrees. All right, well, I'm looking for cotangent of 45 degrees. So again, thinking back to my table, I'll go ahead and do this one. Just want to make enough room. So I'm just going to erase all that stuff. Okay. So now if I'm looking at 45 degrees for my reference angle, well, this here we had our 2 and our 2, and if we take the square root and put it over 2 like we do to all these numbers, we can't actually simplify these guys, and so you just leave it as root 2 over 2. And so that point here is root 2 over 2. And root 2 over 2, and then you decide, well, are they positive, negative? Well, if we're in the third quadrant, that means to get to this reference point here, we had to go backwards in the y direction, and x direction backwards, and then we also had to go down in the y direction. So actually both of these are going to be negative. All right, and now we can go ahead and say, what is cotangent going to be? Well, cotangent is the opposite of sine. Goodness, why do I keep, sorry. Cotangent is the opposite of tangent. So if tangent, we know tangent of any angle is sine over cosine, or in other words, y over x. That means cotangent then is that flipped around. So cotangent's x over y. Well, guys, if the x and the y are both the same thing, so we know that the x is negative root 2 over 2 and the y is negative root 2 over 2, don't even worry about trying to go through all the process of simplifying this fraction within a fraction. Anytime we divide by something that is the same on top, it's just equal to 1, right? And a negative divided by a negative makes this a positive 1. And so our answer for part C is positive 1. All right, let's go ahead and do, let's do part F, okay? So I see I'm 5 pi over 4. So again, I'm gonna draw my x and y axis. I know that over 4, well, that was when I went for a radian measure. I went in increments of every pi over 4 during class. And so all my pi over 4s lie halfway between the quadrants. Again, pi over 4 is the same as 45 degrees. So if a quadrant's 90 degrees, 45 degrees will be right in the middle, like I've drawn the blue lines. All right, now we want to count to 5. So to this first blue line, that's 1 pi over 4. Then we get 2 pi over 4, 3 pi over 4, 5 pi. Oops, I skipped 4. I don't know how to count. Okay. 3 pi over 4. Then this would be 4 pi over 4. I'm just not simplifying them, but that's the same as just pi. And then one more would be 5 pi over 4. So we would have our terminal side right here. And so the reference angle for this, well, the angle created here between our terminal side and the x-axis, every pi over 4 is equivalent to 45 degrees. So my reference angle here is just pi over 4. Yes, it's equal to 45 degrees, but if I give you radians, go ahead and leave your answer in radians. Okay, so this guy right here, the reference angle is pi over 4. Okay, and so now I want to find, well, what is the exact value of tangent at this point here? Well, any pi over 4, as we see in our 45-degree angle here in our table, again, I didn't write the radians next to it, but that's the same as pi over 4. The x and the y values are both the same. They're both root 2 over 2. That's going to be true for any angle that we've created going in increments of 45 degrees, or pi over 4. So there's our coordinate point. Now just decide, well, which one's positive and negative? Well, to get to this point here, I had to go backwards in the x, down in the y direction, and so both x and y are going to be negative. And so tangent, well, tangent is y over x, or sine over cosine, so you can just put negative root 2 over 2 divided by negative root 2 over 2, and just like in part C, that is going to be equal to positive 1. All right. Okay, so I'm gonna do part D now, and for this one, where's my pen? There we go. I'm just gonna erase some of this stuff here. All right, so for this one, again, we do want to find where does the angle fall, but guys, notice that our denominator is 4. That means that we got this radian measure going increments of pi over 4 around the unit circle. So we already know that the coordinate point of this 17 pi over 4 will be the same values as that root 2 over 2, root 2 over 2 that we see in the table here. Okay, again, because if we're going in increments of pi over 4, based on our denominator, well, every 45 degrees, if we have a reference angle of 45 degrees, we're going to be using that point on the table. All right, so now just figure out which quadrant do we lie in. Well, we know a full rotation around the circle is 2 pi. So if I go 2 pi around the circle, okay, well, how do I know how much of 17 pi over 4 that is? Well, 2 pi, guys, is just the same. 2 pi is just the same as 8 pi over 4, okay? So that means when I went a full rotation around the circle, I just went 8 pi over 4. If I go a second rotation around the circle, well, I'd have to add another 8 pi over 4, and that would give me 16 pi over 4. And so that means to get to 17 pi over 4, I just have to go one additional pi over 4. Well, pi over 4, just one more one from where I'm at, will land right there. Okay, Okay, so 2 full rotations, and then I had to do 1 more pi over 4 to get to 17 pi over 4. And so I know I'm going to use the reference angle of 45 degrees, or in other words, pi over 4. I'm just simplifying ref angle for reference angle. And since pi over 4 is our reference angle, that's how we know, looking at our table, that this point here is just going to be the root 2 over 2, comma, root 2 over 2. And since we're in the first quadrant, both of these values remain positive. And so now you just say which one is sine. So sine of this value is root 2 over 2. Cosine would also be root 2 over 2. Okay guys, so there are the examples we did not do in class. There is a review example at the bottom of your page also that we did not get to. For this one, I'm not going to work it all the way through, but I do recommend that you try it. And so you're given sine and cosine, and I'll just set you up here. So given sine and cosine, find the value of each of the remaining trig functions. Well, remember, you can draw a triangle. Okay, and so if I'm given a triangle, I always like to put my 90-degree angle in my bottom right-hand corner, and I'll just choose this guy to be theta. So I'm drawing a triangle here because I need to figure out, all right, well, where do these values lie, the root 10 over 10, etc. So I know that from my angle here, we have an adjacent side, hypotenuse, and an opposite side. I see cosine and sine both have denominators of 10. Think SOHCAHTOA. So this is the opposite, this would be the hypotenuse, this would be the adjacent, this would be the hypotenuse. So the hypotenuse is going to be equal to 10. Adjacent to this angle will be down here, and that is the 3 root 10 over 10. And then the opposite side length of the angle is going to be that root 10 in my sine function. And so now using these 3 values, you can find the values of the remaining 6 trig functions. All right, just like we did on the test. All right, guys, and then from this point on, the second video follows the rest of this. All right, bye, guys.